Hello, this is going to be chapter 8. You've made it more than halfway, so congratulations. Um, in this lesson, we're going to look at two things. We're going to look at systems of equations, and you can see right here that the definition of a system just means two or more equations. So we're going to have both an x and a y in possibly in basically two every time. We don't do the ones that have three equations and three variables in this course. And this lesson will also cover how to solve that system by graphing, and I'll talk briefly about the different ways to solve a system. And we'll look at those in future sections. So if we have more than one equation, how do we find a solution? Well, a solution is any ordered pair that makes both equations true. So just to get a handle on that, our first couple examples just say determine whether or not 2, 1 is a solution. And so remember that our first number in our ordered pair is the x, the second number is the y, and then we're going to go ahead and plug it into each one. So we're going to put a 2 here and a 1 here. We're going to put a 2 here. Be careful, I switched those variables, and a 1 here, and we'll see what happens. So 2 minus 1, does that equal negative 1? Well, 2 minus 1 is 1. 1 does not equal negative 1. And so before I even plug it into this equation, this is not going to be a solution. But let's go ahead and finish up the problem, because even though it doesn't work here, you can have a situation where it works in the other one. So you really do need to check both. So if I plug 1 in for y, and then this is negative x, so that's going to change that positive 2 to a negative 2. Negative 2 plus 3 is 1. So just be careful, because we might have plugged this one in first, and then you're like, oh my gosh, it worked. But when you substitute in for the second equation, it doesn't. It has to work for both. So if you'd like to try one of those, feel free to stop and pause, always, anytime. And so I'm going to plug 6 in for x, a negative 1 in for y, so I would get 6 plus a negative 1, and is that equal to 5? Yes, it is. And then I'm going to plug 6 in minus 2, parentheses, negative 1, and let's see if that equals 8. So 2 negatives, change that to a positive 2. And so it looks like I did give an example where one works and one doesn't, because this is definitely a yes, it is a solution. All right. So now we're going to flip it. This isn't going to be given to us. This is what we're going to be looking for. We're going to be looking for the solution. So how are we going to find those? What are the various ways in which we do that in math? You can find by graphing, you can find by substitution, you can find by elimination, you can use matrices, you can just plug it into your calculator, but we don't encourage that in this course, because we need to, we're really seeing, can you learn the method? And so these are the three we talk about in this course. We do not cover matrices, even though it exists. I am not sure why. Maybe you do that in college algebra. So, all right. So here we go. Let's see if I can get rid of that outline. So graph both lines and determine the point where they intersect, and that's going to be our solution. So we want to make sure that we have both of them in that y equals mx plus b, our graphing form, our slope-intercept form. So if they aren't written like this originally, we have a little bit of manipulation to do before we graph it. So here we just need to jump that negative x to the other side. And you guys are probably getting really good at this because you've had a lot of practice by now. So y equals x plus 1. And here we have to take also the x to the other side. So subtract x, and y equals negative x plus 3. So let's graph. We are going to have a point on positive 1. And then it looks here like my slope is 1 over 1. So from this dot, I'm going to go up 1 over 1, up 1 over 1. And I am going to draw a line and try to make it super accurate here, even though I always kind of have to guess. Here we go. And it should go right through that diagonal there. Okay. See if I can get that down just a little there. All right. Second, because I want to make sure that where it intersects, it's going to be a little bit easier for you than it is for me. Just put a straight edge there and draw your line. Kind of have to guess. I don't have as much control here. Okay, let's switch colors. Now we're going to go up 3, 1, 2, 3. And then it looks like my slope is negative 1 over positive 1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And I didn't know where these would cross, so I really want to make sure that it's an accurate graph so that I can tell. That's why I was really messing with that right there. You can see right here, this is going to be the solution. But, oops, if your graph is off, it's hard to tell sometimes. Let me take 2 on that. There we go. And so you can tell that the 2 graphs intersect at the same point. And so now our job, you're not done when you graph. You definitely need to write that point of intersection. And so the point would be 1, 2. And I have made sure that all of the examples in the notes, all of the examples in the homework in which you're expected to graph, you're not asked to graph, like to figure out the fraction. It's not going to be a fraction. It's not going to be a decimal. It's going to work out to be a nice, clear corner where they graph to help you out there, to help all of us. It's hard to graph those and then estimate the fraction. Okay, let's just keep, that's the lesson. This is the basis of all of section 8.1. So I just have a variety of examples. Feel free to pause and try some on your own and then watch and see if you got it right. Basically at any time you're comfortable doing so. This equation's already in y equals mx plus b form. So let's go down 1, draw our dot, down 1, right 3, down 1, right 3. You might even want to go up 1, left 3, just so that you have those dots really defined. And then draw your line. You can see I messed up right there, but I hit the dot. So I'll make adjustments if I need to. This one needs to be switched into y equals mx plus b form. So I am going to take that 4x to the other side. So we have minus 3y equals minus 4x plus 18. Divide by negative 3. Divide by negative 3. Divide all 3 of them by negative 3. And then note that 2 negatives there is going to change that slope to a positive slope. And then a positive 18 over a negative 3 is negative 6. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. I'm going to go up 4. 1, 2, 3, 4. Right 3. 1, 2, 3. That's going to be my solution. So I don't really even need to continue to count that out. I just need to make sure I connect those dots. And I can adjust that. It really does go exactly through that corner. So what point is this. It looks like we went right 1, 2, 3, and down 2. So the solution is 3 comma negative 2. Again, graphing it is not enough. Let's keep going. Is there another one on this? Oh, there's another one on this page. My bad. All right. So solve by graphing. First one's already done for us. So up 2, put my dot. My slope is 1 over 1, so up 1, right 1, or down 1, left 1. Your choice on that. My second equation, let's take that 2x to the other side. And I get 3y equals 2x plus 4. Oh, I feel... Oh, I must have copied this one down incorrectly because this isn't going to divide out nicely. And I just got done talking about how we weren't going to have fractions. So, divide, divide, divide. Let me pause real quick and check my notes. All right. It will work better if I just make a quick adjustment here. My apologies. I must have just copied this out of my notebook incorrectly. Let's change that to a 6. And let's change this to a 6. And now we can move forward. We'll see what happens. So y equals 2/3 x plus 2. So let's go over here and graph it. We start at up 2, and I think this is exactly what I wanted to see happen. So up 2 over 1, 2, 3. But you already kind of see that we've hit that intersection spot. These ones don't really have that different of a slope, but they're going to cross right there, right at that y-intercept. So what point is that? That y-axis. What point is that? That is the point. Remember, we didn't go left or right any, so that is the point 0, 2. Thanks for sticking with me through that error. Let's keep going. All right, it looks like we don't have that many more to look at. So just some variations on the same topic, on the same theme, graph, find the intersection. As you see, there's some special cases down here we're going to look at. So don't forget, a nice way to review here, if it's x equals a number, it's going to be a vertical line through whatever that number is. If it's y equals a number, it's going to be a horizontal line. So we have a vertical line through x equals 8. It's a 10 by 10 graph, so I know that x equals 8 is going to hit pretty much right there. And then my horizontal line through -1. So there's -1. Move that down just a little bit. That's better. But it's pretty clear where that intersection point is going to be. X is going to be 8, y is going to be -1. And then we move into some special cases. So let's solve this one by graphing. I gave both in y equals mx plus b form. So the very first one, we're going to go down 2. And then our slope is -3 over 1. So let's go down 3, right 1, down 3, right 1. Draw our line. You can also go up and to the left. So that's good enough for my purposes here. Let's graph the second one. We're going to go up 5. 1, 2, 3, 4, 5. And we're going to go down 3, right 1, because my slope here is the same. Down 3, right 1, down 3, right 1. And we learned in chapter 3, we looked at parallel lines having the same slope, and you learned it in theory, but here you might have examples in which you graph them, and you can see right there, they're coming in at the same angle. They're never going to cross. They are parallel. So when the slopes are the same, or equal, just to save the writing space. So we have parallel lines. And when that happens, they don't cross, so we literally say we have no solution. Let's look at the other special case. This one looks a little bit trickier. Pause the video if you'd like. You can practice solving for y. I might just do this real quick. You can see how to kind of do it without writing all those steps. If you jump that negative 2x over the equal, it's going to be positive. So I can kind of save us a step there. And then I know I have to divide everybody by 3. So instead of writing it down, 3 goes into 6 twice. And then here, I know if I jump that 8x to the other side, it's going to become a negative 8x. And then if I divide everybody by 12, I get negative 8 over negative 12x. A negative 24 over a negative 12 is a plus 2. And then if I simplify this fraction, both of them are going to be positive. And I can take a 4 out. So it actually reduces all the way down to 2/3 x plus 2. So I can graph these, but take a second and look. It's the same line. This is the same slope and the same y-intercept. It's exactly the same. If we were to graph this, it would just be 2 graphs that are literally on top of each other. One would be, and I'm probably not capable of drawing that exactly, but it would be this line, and then it would be straight, oh, I didn't do too bad, straight on top of each other. It's the same line. When that happens, both lines, every point on one line is a point on the other line. We say there are infinite solutions. Oops, sorry, I must still be in line mode here. We say there are infinite solutions. So that's everything you need to know as far as solving by graphing. The next lesson, 8.2, I'm going to do on a whiteboard. Just again, I think it's important that every once in a while you see me personally. So I'll teach that one on the whiteboard, and then the rest of them are a little more complicated, and so I decided to do them here on my slate. So you kind of have a variety of lesson styles with this chapter. Hopefully that meets different people's needs and wants. So take care. I hope you find success on this homework. Bye-bye.